Friends, neighbors, and of course the YouTube comments section. What's up? It's your boy. It's me. It's not really your boy. It's kind of your boy. Anyway, happy Monday. We're building things today. We're building distros today. On today's episode of Stop What You're Doing and Do This, no, stop what you're doing, now actually do this, no, actually stop what you're doing and do this, we have the LM Tour Systems 260268 TRUE1 Distro Box. So, this is specifically intended for those of you who are traveling between the United States. Happy birthday, United States, coming up this week. Not only America's birthday, my birthday on July 4th. This is my last week of my 30s. Can you tell that my voice is getting older, more gravelly, more distinguished? No? It's still nasally and super fast talking? Yeah, I know. Anyway, where all my cancer's at, all the feels. But anyway, this is the 260268 box. This is intended for people who are taking systems to Europe. You know, a lot of modern power supplies and things like that are designed for 120 volts or 240 volts. And this is a TRUE1 only version so that it can be compatible with both American voltages and European voltages. I mean, again, it's all single phase, but you know, there's a lot of things like, you know, that are fine. So we do have this big warning on the front that says confirm system voltage prior to energizing this unit and/or connected equipment. So this is a practice on how many TRUE1s can we fit in a 1U chassis, and the answer is 10. 10. We're also using the letter I, which I never use. Me in the New York City subway, we don't use the letter I, because is it 1 or is it I? But I would guess that all of you, if you're looking at these with letters, you can figure it out. Are the letters really important? No. But does it help you with troubleshooting to say that Jack J isn't working? Yeah, sure does. You know, and again, we also have this confirmed system voltage prior to energizing the unit and/or connected equipment on the back. Will anybody read it? No, absolutely not. But the idea here is, I know that a lot of people hot rod their distros anyway and they take them over to Europe. We've certainly built them. You know, the thing is, you have to make sure that the output receptacle matches the voltage. This is imperative. I've seen a lot of things blow up because, you know, you're using, you know, an L630 or an L530 to do an L630's job, right? Two hots and a ground versus hot neutral ground. Hot going down the neutral bus, not the best thing. So a TRUE1 connector is rated for both 120 and 240. I will assume that the astute electricians or electrician adjacent, which I would consider myself, would know that it doesn't really matter, and actually the higher voltage is less harmful. It's the amps, not the volts, right? You know, your common power line going down the street in North America is 10,000 volts, and I don't know how big that wire is, but it's not 3 feet thick, so you know. Anyway. So this is our box. So I figured that I would build this on camera because on the last week of my 30s, I think that my self-esteem is at an all-time high, and boy, do I need it knocked down. So YouTube electricians, do your worst. So anyway, this is the built one. I built 3 of these, and I think I finally have the interior routing solved so that I don't look like an idiot. Usually I just do the riskiest thing and build the prototype on camera, which always never goes well. There's always too much wire. There's always that kind of thing, and I get roasted for it. But this time I actually built 3 of these, or no, 2 of them. This is the 3rd. We have to build 4. I figured it's good, and you know, Ben has to work, so I kicked him out of here so I can shoot this video on a Monday morning. So anyway, I am gonna get all of the TRUE1s tinned and soldered and etc., and we will start populating connectors into the chassis. Coming up next, this is like a cooking show now. I drank this much coffee. And through the power of editing, happy Valentine's Day. I got you these flowers. Perhaps this will be the thumbnail. It's got tons of rage bait on it. It's got a messy desk, tons of crap, TRUE1s that don't have disconnects on them, that are just soldered, everything to make YouTube light on fire. Anyway, I'm going to get these mounted in our back panel here, which is about as interesting as watching paint dry. So, yeah, we'll get those populated and we'll check back in. Alrighty. So here is this spaghetti. Here you go. It's more of a bucatini, really. But there you go. There we go. There you go. There you go. There you go. This is the point where I've lost my mind. I feel like all of these videos are just becoming more and more unhinged with the lack of sleep that I've been having. Ben and I have been leaving here at midnight every single night for the past few weeks. And, you know, did you check out our travel vlog video? Did you see that? See what we've been up to? We've been sneaking trade shows and stuff in there in between all of this hectic crap that we're building. Anyway, let's get the front panel populated. So again, this is another 3 TRUE1 output, so you have outputs on the front. There will be a breaker that goes in here and the input. So we will get this populated. That's right, populated. The front panel. Again, losing my mind. Okay, so now that we've got our front panel filled up, we're going to do some terminations here. So on breakers, you have what's called the line side and the load side. That is the input and output in breaker terminology. The line side is the input. The load side is the output. So what we're going to do here is we are going to hook up our powerCON, or our TRUE1 input here. So we're going to make a cut right here. I should have done this before I loaded the connector, but hey, learn from my mistakes. We're going to cut that guy off, and we're going to use what's called a ring terminal, which is this guy. And we are going to crimp a ring terminal on the end of here. And did I not get my crimpers? I have every tool on earth on this desk except the one I need. Stand by. See, kids, that's why you got to clean your room. Crimp this. And then the other thing we're going to do is we're going to power our meter off of this as well. So I'm just going to strip this guy back a little bit. So I take the meters. Generally, when we do distros, I will take the meter. I'll take the meter and put it on the line side of the breaker so that as soon as the panel is electrified, you know your voltage. This is especially true for these guys that may have 120 volts. They may have 240 volts. So if you're using the breaker like an on-off switch, it's a little tug here. This is like the world's thinnest wire. So if you're using your breaker like an on-off switch, you know what you're getting before you flip it, before you energize the system. So we will do that. So I always like to put it on the line side. In bigger systems, it's not really important. Sometimes I like to make it when so that when you flip the breaker, the meter turns on, so you can quickly see if you have power or not. This is not one of those instances. It's already kind of scares me that people are using this in a dual voltage thing, but you know, I feel like if you're touring in Europe and America, there's at least a chance that you kind of sort of know what you're doing. So, you know, we've got that. So the only thing we really have to do now is we have to tie our neutral in with our main neutral. So generally what I like to do with that is I will just connect that guy with a butt splice. Which is one of the funniest things, at least for me, being a 40-year-old child. So what we'll do here is we will strip this guy back, and we will strip this guy back, and we'll solder them together. So I will do that because I don't know where all my stuff is. So stand by. So one of my favorite things about the quad hands, helping hands, is they have these magnetic arms that come off. So if you're somebody like me that lives in a world of chaos with a messy desk like this, and you need to get your helping hands in here, you can stick these little guys to anything. So oftentimes when we're doing fans in racks and stuff like that, I'll stick these to the rack rail if we're soldering. They are hugely, hugely helpful, if nothing else than for the little hands. Look at this ridiculous stuff I'm doing right here. This is just on on the crimper, or yeah, the crimper. I said the right word. Sorry, a little stressed. We have a lot of deadlines here this week. It's always, the holiday weeks at LM are always insane. I always joke that if it's Arbor Day, you know what I mean, Flag Day, some innocuous holiday like that, there will be 30 people that call and say, I'm totally screwed and need my cases right now. And we've got 3 different tours that all have a July 1st deadline where they start loading the trucks. These are going to Europe, so we are doing them first because missing that truck is real expensive on our side. So because this wire is so dainty, and delicate, I am just going to solder this together so that it always is there to my neutral. This is my main neutral. So again, if the system has power, the meter has power. So you're getting the hot at the breaker, and you're also getting the neutral at the input side. So what we'll do here is we'll use a butt splice. This is just a 10 to 14 gauge or a 12 to 10 butt splice. I usually use the 16 to 14 ones. They'll fit on 12 gauge wire, and I like them because they're nice and tight. But again, what we'll do with this guy is we will not only use this, and then I like to hit it on the 12 gauge crimp. It's also great to crack your knuckles too. And these are cool because they have heat shrink on them also. So it's not that it really does anything, but you know, we have this dainty wire with our 12 gauge wire in here. You know, so oh God, I should have never told you guys that I'm using 12 gauge wire in here. I can already feel the comments. You should use 10 gauge wire. Guys, it's only rated for 20 amps. You don't need to use 10 gauge wire in here. It's fine. You know you have 14 gauge wire in your wall in your house, right? Right? Which always is astonishing to me. Everything in my house is wired with at least 12. Whoever buys my house is going to be like, what psycho lived here? All right, so we're just going to give this a pull. Nothing's coming out, right? Little guy, big guy, big guy. All right, we'll just shrink this down. Here's your daily heat shrink moment. Okay, we're under a heat advisory this week, so it's always nice to have the photo lights on in the room and a 1,000-degree heat gun going on while you're sweating your cojones off. Okay, so the next move that we are going to do is we're going to crimp another ring terminal on this guy, and this is going to feed the load side of the breaker, and then we will get the chassis assembled. Okay, so this is our chassis bottom. So on this, we are also going to put a ring terminal on a piece of green wire. This is going to be our chassis ground. So the way we do that is there's a little press bolt that's in here. We're just going to put this on. And this saves us in a couple of different ways sometimes. You know, there's always a lot of grounds. So, you know, with this, with the chassis ground specifically, you know, you're depending on how you're grounding your chassis, sometimes people will ground the chassis, the caps, all that other kind of stuff. So when you have a stud like this, it allows you to put many ring terminals on it, so it saves you in your summing. You know, the breaker is like that too. I usually just don't like to stack up a bunch of ring terminals on there, although you can. You know, oh, can't forget our little ferrite choke on there. We need that, or the meter won't work. So, all right, I'm going to get the chassis assembled on this now, and we'll start terminating. All right, so look at this box. If this box isn't an absolute metaphor for my life right now and this desk, I don't know what is. This is probably, I should make this the thumbnail. This is like the most rage-baity thing that I can put on. I should do that. You guys will love that. All right, so we're going to terminate now. So what I did, I put this little ferrite on there. This is going to be around my, my hot leg here that is going to eventually terminate into a Wago, which we have these 6-position walnuts that I usually like to use for these. They're great. You can't mess up with these. And we only have 3 left. So this is going to be a combination of the walnuts and the and probably inevitably the 5-position Wagos. So we are going to get neatening up. Let's see. What do we want to start with?
I like chestnuts better.
Ben prefers chestnuts.
Instead of walnuts.
Walnuts roasting on an open fire, except that's a double entendre because it's spelled wall, W-A-L-L-N-U.
Well, if you wire it wrong enough, then you have the fire to roast the chestnuts.
Oh my God. All right.
Sorry.
We're going to pick one. We're going to pick neutral, ground, or hot, and I'll see whatever yields the easiest cable path to get stuff out of the way, and we'll start with that, and we'll check back in. Okay, so our hots are terminated. So we have a 6-position walnut and 2 5-position Wagos. So the walnut, that's one way in, and that's it. It's like marriage, Catholic marriage. Nah, maybe not. So what I like to do with the Wagos is we put little pieces of heat shrink on them so that they can't accidentally open. The lever nuts or the walnuts are permanent. They can't, once they're done, they're done. So with these, we just put heat shrink all over them. This particular distro, I mean, again, we designed this specifically for this client. And I just thought, we'd get lots of requests for, like, how many TRUE1s can you put on a panel? And I'm like, well, so the client ordered 3. I built 4 chassis. And I'll have 1 in stock. So if you guys want one of these, with all the electrical code violations that I'm sure you're accounting, you can buy one from our web store. There's a link in the description. So with these, this is a prime candidate to get a PCB made. You know, it's like that would, make this whole thing way easier to build. And it would also, you know, cut down on the thermocoupling that will inevitably happen with this big bunch of wires right here. I mean, again, we try to keep this as neat as we can, but on the same token, you know, you are shoving 10 powerCON or TRUE1s into one box. I mean, you know, they need wired, and that wire has to go someplace. So as much as we do try to keep everything neat, as I'm desperately trying to do right now. I mean, again, I know that this looks a little crazy right now. So you saw me wrenching on this wire like this, right? Generally what I like to do is I like to bend them up so that they sort of get out of the way and you can have a nice, neat path that goes in there. One of the other reasons why we solder and we don't use the crimps, which, again, somebody pointed out in the other video that Neutrik actually makes a specific disconnect with the, and I can't remember what they said, it's a standardized crimp. But again, the reason why we don't do that is because we're building heavily densely populated chassis like this. You know, even if this is really on there, you know, there's still a chance that it could wiggle loose, and with a solder, it's just not going to do that. So I know that some of you have said that you have fixed poorly soldered connections. I assure you that I know how to solder. At least according to me, not some of you, but they're good. I promise. We don't melt anything on there. Well, I mean, you sort of do because you're soldering, but anyway. All right, I'm going to get the neutrals or the grounds. I don't know. I haven't decided yet, and I'll check back in. Woo! We are getting there. Look at this. I mean, again, I try my best to keep this stuff as neat as I possibly can. I want to see one nice straight line that goes down the center, and just sometimes that's possible and sometimes that's not. So here's where we're at. I kind of did the neutrals and the grounds duplicitously. You know, here are my feed tails that are coming at this point to go into all of these malt blocks over here. But we're pretty much in there. So I am trying desperately to try to land this in a neat way. I think I'm going to make my grounds on this side sort of end up around here, and then maybe I can make my neutrals peel off. But you know, the problem when you, it's funny, every time we do one of these, someone always says to you, can you fit it in a 1U? And although I understand that rack space is always at a premium, it is much easier to do things in larger boxes. So this is an experiment into how much we can cram into a standard 1U chassis. If you notice, a lot of other manufacturers Kali distros with a 50 amp They'll do them in 2Us, and the actual flanged inlet connector is sticking above the chassis because it's a little bit higher than 3.5 inches. And I do ours specifically in a 3U, and we get requests, can you do it in a 2U? And I just won't do it because I'm not interested in wrangling 6-gauge cable into that small of a box. I just can't. It hurts my brain. So anyway, I'm gonna get the rest of this done and check back in. All right, here we go. The neutrals and the grounds look awesome. The hots kind of look like crap, but that's okay because no one will ever see it. So before we close this thing up, let's just energize it. Let's just energize it and make sure that everything works. I should do my Chris controls thing when he has the explosion. There we go. Look at that. So now we just have our little shop test cable that we use here. And we are just going to see, look at that. Correct. And 116 volts. The meter says 117. The Klein tester says 116. What could go wrong? What's a volt between friends? Can't imagine that the tolerance on these are like amazing. Okay, so I think that's good enough to close. And then we'll test all of them. And yeah. Oh, good. UPS is here, Ben. Our TRUE1 connectors have arrived. All right, so here is the closed up patient. Lots of TRUE1s. Lots of TRUE1s. So, as we do our final test, if you have any questions, leave a comment below. I would encourage you all to be nice. You know, I will say that we do these videos for free. So, for those of you who are kind of shitty about commenting on a free video, you know, understand that the price is the price of admission. You're shitting on a free video, guys. Just put that into perspective here. But I will encourage you that if you are gonna shit on a free video, just subscribe. At least give me 10 cents while you shit on me. Sorry, I try not to swear on these videos. I'm exhausted. I'm about to turn 40 this week. That's messing with me. I don't really want to do that. That seems like it's a pain in the butt. So let's just make sure that our voltmeter or our amp meter works using our very scientific tester. Look at that. 10 amps down to 107 volts. Clearly there are some things on this line. So if you have any questions, you can leave a comment below. You can also email me, billy@billylaguardia.com. And yeah, thanks for watching. Happy 4th. Happy birthday, America. Happy birthday, Billy. I will see you guys on the next one. Bye. Just when you thought you were out, you're back in. So check it out. I think this is the 4th one that I've made so far. And look how much neater the wiring is. So I admit I am a glutton for punishment with building my prototypes on YouTube. But just so you know, it's real. But look how not nice and neat it is. There's all of the scrap cable that came out of it. So now we're actually going for real. So again, thanks for watching. Messy Desk Productions. Happy 4th.